now it is my pleasure to introduce the keynote panel. The keynote panel is very special because it has number of leading service providers and the leaders from the service provider companies that are at the leading edge of using SDN and NFV. Okay, and so the charter or the scope I specified is for them to discuss specific solutions deployed or soon to be deployed, benefits that are realized, role of open source in this transformation, and migration strategy. At the end, we will have at least half an hour or more for discussion and questions and answers. So I will urge you to be ready with questions and answers. Okay? So let me start with the introduction of our speakers. So we have Andre Fuich. He is the Senior VP and responsible for Domain 2.0 at AT&T. Okay? So welcome, Andre. So as I mentioned, so he is responsible for Domain 2.0. As you know, that is the big program AT&T has launched in order to transform its infrastructure. And this is the guy who is responsible for it, and it's a real pleasure to have Andre here. In his career, he has done everything, software, IT, networking, and all that. And to me, what is more interesting is that he's from Bay Area. So when I talk to him, I find him very easy to communicate with. He grew up here, went to Berkeley and Stanford both. So that's great. Our next panelist was supposed to be Vish Nandalal from Telstra. Unfortunately, he got ill and he's not able to be here. But I'm delighted to let you know that we found a great replacement on a short notice. That is Kangwon Lee. He's a Senior VP of R&D at SK Telecom. So welcome, Kangwon. And so he's responsible for network, IT convergence, and all that. And he graduated from a school in US as well as spent many years at IBM. And so he's very familiar with Silicon Valley and how innovations happen and so on. So that's great. And finally, last but not the least, our panelist is Yukio Ito-san. He is from NTT Communications. He has been kind of a regular at Open Networking Summit. So welcome, Ito-san. So as you know, he was the founding board member of Open Networking Foundation. He's on the ONS board, and he has been a big champion of SDN, NFV, and a very early adopter of SDN as well. So this is our very distinguished panel. I want to pass it on to Andre to get him started.
Okay, thank you, Guru. Hey, good morning. Welcome. All right, it's a real pleasure here to be here this morning. And so Guru, when he asked me to join this panel, he said, hey, we don't want to hear about fluff and PowerPoints. We want to hear about real action. What are you guys doing at AT&T? And I'm here to tell you that when it comes to SDN and NFV, we are all in. And so I want to talk to you about some of the services and products that we have in the market today that are SDN and NFV based. The first one I want to mention is our Network on Demand service that's out there. We're actually just in the last month opened it up to over 100 cities. This is basically an enterprise layer 2 play that allows enterprise customers to dynamically manage the bandwidth between their sites. This is basically SDN controlled based on the ODL controller. We also have mobile call recording. This is another great example that we have out in the market, a service that allows, again, enterprise customers to extend call recording functionality out to mobility devices to track calls. And this is basically out of some of the banking regulatory requirements that are out there. This service is basically is a great example of orchestration and VNF service chaining. That's out there as well. And then we also have in the mobility space for our mobility resellers, our mobile virtualized network operators, we have a virtualized evolved packet core, a mobile packet core that's completely virtualized in service in production today with lots of subscribers running on it. So those are some examples of products and services that are out in the market today, and this will be growing quite rapidly as we go into the future. So that's on the external side of what AT&T is doing, but I wanted to talk a bit about internally around what changes we've made around our process as well as our culture. So if you remember Drucker's old adage, right, if you can't measure it, you can't manage it. We spent a lot of time putting together metrics and process, a methodology to really gauge how well we are moving along this journey to SDN and NFV. You've probably heard about our big goal out there, that is to virtualize and software control over 75% of our network in the next 5 years. And this is really important. If you look into what that 75% represents, if you look into the numerator and the denominator, we built basically what we call a maturity score index for each network function that we will be virtualizing. And it's not just porting the code and running it in a virtualized environment. We measure it on really 3 basic factors. One is, what's the degree of virtualization? Is it a VNF that's fully decomposed and fully taking advantage of a virtualized infrastructure? We also look at to what degree is it under SDN control. And we also look at to what degree does it plug into our new operational management framework. And this is really critical because this is where our orchestration, policy, automation, all of that good stuff occurs. And so when you look at those 3 dimensions here, those are the metrics we use that are measuring our path to 75%. Also, it's also important too to create a bridge from incubation out to production. So we've created a sandbox, if you will. We call it our incubation and certification environment. This is an environment now that we've opened up to our certified Domain 2 suppliers so that they can land VNFs into our environment, start working on our stack, start working with our operations management framework, and then we can start working to build them and eventually move them into production. Lastly here, I put down culture, and this is about people. And this has probably been the biggest challenge for us, especially AT&T, which has a long legacy of a very, very hardware-centric network. We had to make a lot of changes. So late last year, we reorganized our technology operations divisions. We actually converged our network and IT organizations together. So we no longer have separate, disparate islands as we've had for many, many decades. That was pulled together. We also created a dedicated Domain 2 organization with over 2,000 folks in this organization dedicated to SDN and NFV. We also are changing the whole software model internally in the company. Traditionally, we've been fairly closed, a lot of intellectual property captured within inside. Now we're relying more on open source. And of course, open source only works when it's 2 ways. So you'll see us doing a lot more, not just absorbing and consuming open source, but also contributing back. In fact, in the last month or so, we just put out there our policy engine, Zacamol, that's out there now, and that's what we're using as part of our management framework as well. And then skills transformation. You know, this move from a very hardware-centric network to a software-centric network, we wanted to offer our employees a plan, a roadmap to get them on the train here. So we've built an extensive training curriculum for our employees. We've given them a blueprint, a roadmap, if you will, and it's really up to them to follow through with it. Right now we have well over 1,000 folks enrolled in attending and achieving what we call nano degrees with some of our partners out there in education. We also have an alliance here with Georgia Tech with their online master's program in computer science, and we have several hundred employees already admitted and attending classes. So we've done a lot here to get our folks, our culture, in line with this new evolution here, this big transformation upon us. So that's what we're doing today. Let me talk a little bit about where we're going here in the future, and I just wanted to highlight a couple areas here. So SDN NFV moving forward. One area here, in fact, we've got a couple plenary talks this week here that I hope you can all check out. One is that we want to start pushing NFV down the stack. We want to actually get it down into layer 1. We think there's a big opportunity here for us, and not just us, but all large-scale service providers. And the big area here we're looking at is basically in our metro optical space. Basically, we deploy a lot of ROADM technology there. If you look at that technology today, frankly, there's a lot of complexity, closed, proprietary, and expensive solutions there. And we really want to break that apart. So we've got a great talk here. Actually, Martin Burke from my team here will be leading a talk about what we're doing in this space. We have a very aggressive schedule to actually decompose this ROADM architecture and make it much more flexible in terms of how we utilize pluggable optics, how we utilize transponders, how do we get basically SDN control into switching wavelengths. A lot of SDN and NFV has been focused on those upper layers. We really feel there's a big opportunity here to bring this into the optical layer as well. So a lot of good work going on in that space. So please check it out. I also want to highlight in the access space, we also have a great session as well around our fiber to the home, and that is with GPON. And that is, we are looking at decomposing how we deliver and have designed GPON in our network, and we're looking at a virtualized OLT. Tom Anschutz is here, and he's also going to walk through some great work that's going on and some demonstrations as well. This is also utilizing the ONS controller as well to make that happen. And then I'll also highlight here, we see a big opportunity in the radio access network as well. If you look at a company such as AT&T, obviously it's all about mobility, it's all about cloud for us, and we think SDN and NFV will play a big role here in the RAN as well. And a lot of good work is going on in our labs in that space as well. So let me just talk a little bit about white box for the operator. Again, this is a big area for us. You heard earlier from Guru about the big opportunity here to leverage more white box, more bare metal switching, if you will. And this isn't just in the data centers, as a lot of the focus has been of recent. We really want to take this out to our customers, to the premise. We want to take it, as I mentioned, with Cloud RAN, even take it out to the cell sites. We want to take it to our central offices. There's big, big opportunities here. And we really need to see what the great progress we've seen in the switching matrices of data centers in terms of spine leaf. We really need to keep pushing that out to the WAN. Big opportunities there. And then last, I'll just say here, what's so key about white box are just the basic principles around it's got to be about performance, it's got to be about scalability, and of course cost, but also programmability, because this is really what's going to unleash the networks here into the future. So that's just a little slight taste of what we're interested in and working and moving forward on. And I hope you enjoy the sessions the next couple days here, and look forward to meeting many of you. Thank you very much.
So, Kang, so we are going to hold the questions until the end. So
this is,
yes.
Okay. Good morning. Okay. All right. So I come from SK Telecom, and not many people may know about it. So just to tell you a little bit about the background and who we are. So basically, we are #1 mobile operator in Korea. By the way, SK doesn't stand for South Korea because, I mean, many people mistake for that. So now in Korea, we have 3 mobile network operators, and we are the #1 with about 50% market share. And the competition is, I mean, fierce. On the other hand, government regulation is very tight, I mean, in terms of pricing and how to operate. And they are talking about possibility of introducing the 4th operator, so it's going to be even tougher environment. Now, and the customer expectation is very high. We have introduced LTE advanced and with the maximum speed of 300 megabps over the air. And in Korea, you can access your mobile device to connect to the network anywhere, literally anywhere. And they will not be happy if something happens to the network. So that's a very high expectation. And I think we are the 2nd lowest price per data in all the OECD countries. So that's the kind of business environment that we are in. We have been always in the forefront of introducing the new capabilities from CDMA to voice over LTE, LTE advanced recently. So SK Telecom has innovation in its gene. So it's a very exciting company to work for, and it's very natural to look at new technologies like SDN and NFV from our point of view. Now, when you have LTE Advanced already deployed, and it is used by many people, now where do we go from here? And how do we get there? That is the big question that I have to answer and think about all the time. Now, one thing is that, I mean, there is a lot of talk about 5th generation mobile network in Korea, and in many countries looking to advance their wireless technologies. Now, we have a very specific target, which is 2018 Winter Olympic Game in Pyeongchang that will be basically a test bed for deploying this 5G network and see how well it works. And if you think about it, it's not a lot of time. We are talking about like 2+ years to be ready for the commercialization and the field trial. So in this kind of environment, speed to innovation is key. Basically, we cannot just let everything happen in its natural course and then take it. We have to innovate before things actually take shape. Now, there are 2 kinds of issues with 5G. One is the wireless problem, which I'm going to briefly just sketch over in the next slide. The second problem is the platform problem. And this is more relevant to SDN and NFV question that we are talking about in this venue. And by the way, SKT is a relatively small company. We have about 4,000 employees, and we are serving 27 million customers. And so everything has to be done in a very efficient manner. I mean, we don't have an army of software developers or army of network engineers. So in the wireless space, there are lots of new and exciting technologies that are coming up. Massive MIMO, full duplex communications, millimeter waves, and all these things that will try to use the limited spectrum in a more efficient and better way to basically manage all these wireless resources and infrastructure, and also try to operate in a better efficiency. Now, when it comes to, if you look at the macro view of how network has been evolving from 3G network to 4G network, which is currently what we have now, and going forward to 5G network, we feel that the traditional operation of, the separation between network operation and the data center, and the data center has been mainly for managing and building the customers and managing the network devices. They will be fully converged in the next generation. That's what our vision is. And basically, this converged IT and network infrastructure is going to be based on some kind of cloud, basically virtualized server farm. And it will have a lot of these components like radio access network, core network, data center, and the media, and all these different kind of services will be running on top of these virtualized server farm. And in this environment, SDN is something that we have to have. So this picture describes what we think in the logical architecture, how the network will look like in the next generation. In the downmost layer, there is this x86-based commodity hardware. Then we will have virtualized environment where we will have cloud radio access network, cloud core network, and software-defined data center. And they will be managed by some intelligence layer that will orchestrate how these resources will be used. And the green layers are what will be visible by the users. Basically, we want to create virtual network slices, and they work as their own network, basically serving different purposes. So it can be used for media delivery, it can be used for industrial IoT, or it can be used for healthcare, or it can be used for regular telco type of services. And they will have different kinds of requirements, basically. If the virtual network slice is created for media services, then bandwidth will be maybe the most important factor. If it is for industrial IoT, then maybe the latency might be the most important factors. And the main characteristic of these virtualized all-IT network is that it is virtualized and intelligent in the sense that it knows what's happening in the network, and it can be optimized to provide the services it needs to provide. And it should be programmable in the sense that it doesn't have to involve a lot of manual processes to create, say, new virtual network slices when a new service request comes in. Well, I don't think I need to talk about benefits of SDN and NFV too much here, but just to briefly point out some of the things that are done. Currently, it takes about 4 months to deploy new service, new network equipment. We want to optimize this speed. This is taking too long. And we want to be able to efficiently coordinate and control the distributed network elements. So operation efficiency is another key factor. And of course, cutting cost is a very important factor. How do I go back? How do I go back? I think, yeah, okay. All right. So Guru asked me to keep this talk more to the what has been actually happening, not about the philosophy and the overall direction. So what has been happening at SKT related to NFV and SDN? there has been a lot of lab trials since 2012 on the virtual network functions like EPC and IMS. And we have been testing different kinds of SDN controllers, including ODL and ONS, and a couple of demonstrations that have been created related to service chaining. Now, currently, we are working with a major vendor to commercialize virtual EPC. I'm going to describe briefly in the next slide. And we are working on a proof of concept of transport SDN. And right now, we are collaborating a lot with the open source community and the vendors in this area. So one thing that's going on in this year is basically deploying the virtual EPC for IoT traffic. Basically, this is going to be a one-box EPC that contains all these functions in a single box and can be controlled from a single point. And this is a natural area where we are trying the first example of NFV because IoT is a relatively new space, and this doesn't disrupt a lot of the existing network infrastructure. And we will try out and see how it goes, and we will slowly expand the scope of NFV that we deploy in our network. Now, there are ongoing R&Ds and use cases. These I'm going to just briefly give you a highlight and show you what we are doing. So I told you about virtual EPC, but it is right now this year is going to be a relatively limited scope. What we want to develop is a full-scale EPC developed as an NFV and controlled and provisioned and managed its life cycle by the NFV orchestrator. And we also want to run on top of cloud infrastructure like OpenStack and provide open APIs so that we can build new network functions on top of that and basically add intelligence with SDN. The second one is related to the first one. Basically, we want to integrate telco SDN with the cloud interface. So here we are taking steps to integrate SDN feature with the OpenStack Neutron. So basically, we are creating something called simplified overlay networking architecture. And this is going to be, this will provide many of the services that needs to be provided by the virtual network functions, and will provide optimal local routing, and we will eliminate any unnecessary traffic, and provide all these basic network functions as SDN applications, and then we will have scalable gateway that has acceleration technology embedded in it. The third area that we are working on is application level aware service chaining. So far we have tried a lot of examples of service chaining with the layer 3 and layer 4 information. We want to make it more usable and controllable by exploiting the application level semantics. And by the way, 3GPP is also starting to consider L7 service chaining. So in this part, basically there are 3 components that are working together. The first one is something called PCRF, which is determining the high-level policy. The second component is SDN controller, which gets the policy and basically performs the actual service chaining request. And then component called traffic detection function. You can think of it as an entity that can see the application semantic, application level semantic, and actually tag the packet and untag the packet so that it can be controlled, it can be sent on the right level of service chain. The fourth one is related to recovering from the failure in the central office. Basically, in this scenario, we consider multiple SDN controllers deployed in the distributed data centers, which can be, you can think of them as central office now, and have overlays between these central offices. And when there is a failure, then it can have either services that are already running migrate to another location, or have active standby services with high availability. And when active nodes go down, the standby node takes over the service, and all the traffic routing happens automatically. So, I mean, so far, so good, but I mean, adapting SDN and NFV is not without challenges. So the first one is non-technical challenge. So one thing when we talk about SDN and NFV with the networking business unit, what they tell us is that, I mean, they have already invested heavily in the LTE equipments. So now this is a new investment, and this needs a lot of convincing, and how we get to the next level is a big challenge. Another one is something that AT&T mentioned briefly, that, I mean, the workforce right now, they need to be retrained in this new environment. So that's another non-technical challenge, which is significant. The second one is, of course, technical challenge, reliability of these new capability. We need to be sure, because we don't want any disruption in the live network. And the performance, because, I mean, frankly, there are a lot of nice features that are coming with SDN and overlay networks, but they also come with the performance cost. The third one is, I mean, we talk about OpenStack, open source, but when it actually comes to, say, I mean, talking to the vendors of these open technologies, they are not that open. And we want to avoid vendor lock-in. That's one of the main promise. But right now, so far, it is not so clear whether it's really the case. So to summarize, we are preparing for 5G network. Now, it's not going to be just about network bandwidth. It's about flexibility, agility, manageability, and being able to create new services. So SDN and NFV is very important in this area. SK Telecom is not a big company. We don't make all the things that we use. So it is very important for us to collaborate with open source communities and the vendors in this space. And as I briefly introduced to you, the journey has already begun, and we look forward to working with you all. Thank you. Thank you.
Okay. Good morning, everybody. My name is Yukio Ito from NTT Communications. I'm more than happy to have this opportunity to share with you about our activities and adoptions of SDN and NFV technologies. I also show you our trial for transport SDN and virtual CPE. As the first part, I will briefly talk about our experience of SDN and NFV adoptions. The OpenFlow was commercially introduced within our data centers to facilitate enterprise cloud in June 2012 as a world first case. If you look inside the data center, there were a huge amount of routers and switches which will have to be configured manually in past days. The various individual devices settings had been automated through network controllers. It dramatically changed our workflows. At the same time, we started connecting up data centers between enterprise clouds with virtualized network by using OpenFlow. It actually allows customers to back up data between the clouds to reserve a backup schedule from a customer portal and to boost the network bandwidth in real time according to volume of backup data. Now we are offering enterprise cloud worldwide. Eventually, we have utilized OpenFlow in following 3 networks. One is intra-cloud data center. Second is inter-cloud data centers. Third is inter-cloud data center and colocation data center. Next is our network function virtualization service option powered by Virtela Technologies. Virtela is a group company of NTT Communications. Formerly, network devices such as firewalls and application accelerators needed to be installed at the customer's locations. What we have done is to virtualize and provide these functions in the data center servers. Utilizing NFV technologies, appliances such as application accelerators and firewalls are incorporated into the network functions as a software. So the customers no longer have to install these devices in their own premises. It seems SDN technology are already mature level for deployment in the commercial network under certain conditions. It requires users some additional development since it is hard to find vendor products which fulfill users' requirements for real operations. Or users have to order those requirements specifically to vendors. SDN brought us agility for restructuring and updating networks. In next slide, I show you an example of agility in a data center where it required enhanced networks according to the traffic increase step by step. SDN reduced OPEX and human errors as a result of a significant reduced the involvement of a manual operation. Actually, from the start of our service, there was no human error. SDN allows us a realization of multi-domain, multi-layer, and multi-vendor, as I show you in the next part. Our goal in the future is adoption SDN to wide area network. This slide is an example of agility of a reconfiguration network in a data center. Shortly after we had launched the enterprise cloud, we faced the necessity to enhance the intra-data center network because of the rapid traffic increase of our customers than we assumed. But we something problem. Okay. Oh, sorry. How back to?
Go back.
Mm-hmm. Oh, okay. 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 So this is an example, yeah. So, but we could take advantage of the topology-free and flexibility of OpenFlow. So we were successfully able to enhance the network topology step by step, like this corresponding to service growth. We needed to change the intra-data center network from ring topology to tree topology finally. So we inserted core OpenFlow switches as a spine switches and changed partially from high priority components of ring topology to tree topology. It became possible to change a configuration in one night. Previously, it had taken 1 week or more. OpenFlow SDN brings us various benefits. I feel this is largely from merit of the centralized control of SDN. At the next part, I will show you about our trial of transport SDN and virtual CP. Now I'd like to introduce our transport SDN activity. Normally, it is necessary to overcome multi-domain and multi-layer conditions to manage end-to-end connections between data centers. As shown in this slide, currently, operators have to configure these network devices for each domain, each layer, and each vendor. Integration of these operations have to be done by operators manually. These will reduce accuracy and increase operation cost. Our transport network controller allows us integrated and unified end-to-end management under the condition of multi-domain, multi-layer, and multi-vendor networks. This slide shows architecture of our prototype transport network controller. On our trial demonstration, this platform controls OpenFlow switches, mobile backbone microwave devices, packet transport network devices, and DWDM devices. These devices are controlled by different interfaces, OpenFlow network by OpenFlow protocol, and the other networks by vendor-specific interfaces. This platform manages those networks with its network model abstraction functions. With these functions, it provides APIs to control those networks. These APIs abstract the differences of multi-domain, multi-layer, and multi-vendor networks so that we can control them by using simple APIs. This network management platform is implemented with ODENOS and ONS that are both open source SDN software. ODENOS was created in the O3 project, that is SDN-related research project in Japan. Last year, we started to use ODENOS for the network management platform. And this year, we started to integrate ODENOS and ONS. As you may know, ONS, Open Networking Operating System, is a carrier-grade open-source SDN controller. We are using ONS to realize high availability and scalability of the network management platform. Shown as yellow parts, we have developed 4 major applications: network visualization and virtualization, end-to-end optimal path calculation and allocation, and global repair with failure handling. We show 3 scenarios at the SDN solution showcase. First, we show integrated network visualization of multi-layer and multi-domain transport networks. Second, we show a policy-based optimal path calculation and allocation across multi-layer and multi-domain networks. Third, we show old recovery across multi-domain networks. We are making experiments on seamless management of our global networks in the near future. In the experiments, we deploy transport SDN products in our test environment and implement some use cases to verify their feasibility and benefit. We will enhance our network management platform. Especially, we will contribute ONS project to adopt ONS into our platform more efficiently. We will share our concrete requirement of our transport SDN and develop source codes of ONS. We plan to create new use cases. First one is self-diagnostic test with virtual testers that realize zero-touch provisioning and accurate test automation. Second is to optimize our network topology and resource locations. To reduce CapEx and optimize the quality of our service, we need more sophisticated methods for the resource management. The third is the interoperability with OSS BSS systems. To achieve the business process using transport SDN, Transport Network Controller needs to work together with OSS BSS. The last is to reroute in-service networks. We have to maintain the in-service networks to take care of the quality of our service in some cases. Transport SDN enables us to maintain our network more safely and effectively. This slide shows our trial for a VCPE with service chaining across multi-location. This trial provides optimized, on-demand, and flexible virtual CP services by enabling customers to select, allocate, and change the functions at any location. Customers can choose cloud, a carrier network, customer location, or any combination of those locations to deploy virtualized network functions. We will control, manage, and change VNFs to make the best use of NFV. All these functions can be activated from the portal site on demand. Customers can make their orders from the portal site. After that, the portal site forwards a customer's request to the controller. The controller sets the VNFs to the cloud or carrier network or customer premise sites. In our trial demonstration, we show the 4 types of virtual CP solutions: traffic analysis and network defense, cache, URL filtering, WAN optimization. You can see this demonstration at the exhibition booth number 319. Thank you very much for your attention.
Okay, so I guess we did overrun a little bit, but we have time for at least maybe 20 minutes or more for Q&A. So why don't you guys, if you have questions, can you please step up? Let me get started with 1 or 2 questions that I have. So in general, the conventional wisdom, Andre and Kangwon and Ito-san, is that service providers move so slowly. And as a result, if you look at it, venture capitalists in Silicon Valley probably haven't invested in a startup play that is primarily targeted at service providers, okay, last maybe 10 years or so. In your talk, you talked about from sandbox to production. You are also moving very quickly. So what can you tell this community? I mean, this is a lot of people from Silicon Valley. Hopefully, there are some VCs in the audience as well. How is the model changing that you think you will be able to help startups move quickly and be able to benefit from their products in your solutions?
Yeah, so I'll answer that first. So at AT&T, we realized the power of the incumbency. But what we're doing is we're really opening up to disruptors here as well to come in. I mentioned this sandbox to production. This is basically this incubation and certification environment. Right now, we've released some of our VNF guidelines to our select Domain 2 suppliers right now, but soon we'll be opening that up to a much wider array of disruptors to come in. And this way, they can come in and land their VNFs on our platform, prove to us that they can quickly integrate, operate, and perform at the scale we need. And that, frankly, will really shortcut a lot of this sort of legacy certification, validation process that, frankly, would take months up to years in the past. And so we really think this will streamline that whole process.
So, Andre, is there a success story that you can share, or this is too early to be asking for a success story there?
I do have some success stories here, but I don't want to name some names yet without vetting those right. But I can tell you, I mentioned the mobile call recording service that we did, and this is a good success story. We took a variant of that architecture, which is basically service chaining together a virtualized instance of IMS with a virtualized instance of load balancing, firewall, so on and so forth. We took that template and created for a customer of ours another type of product, if you will, within less than 12 weeks. Okay, so that's 3 months. That was probably one of the fastest concept to actual production and delivery. We actually have about 3,000 subscribers on that particular service today, up and running in production. So that's...
Oh, that is definitely a good success story.
A good success story for us.
So, but Kangwon, you also said that you want to, because as a smaller service provider, you want to primarily work with vendors. What can you say to help startups to be able to move more quickly? Are you changing your basic model? I'm Kangwon.
Okay. Yeah, I think what's happening right now is that, as Andrea said, I mean, there is still, very strong foothold by the incumbencies like Ericsson and Huawei and Nokia of the world, because they are not waiting. They have also taken the concept and embraced the power of openness and the data center-based network functions, basically. They are coming with full force. And they definitely know what it takes to build reliable carrier-grade network functions. But what's interesting is that it's not the traditional pipe service only going forward. We are talking about a lot of intelligent new type of components, like whether it's a CDN, whether it's local firewalls, and all these traditionally IT components. That you can find in data center. Those features are more and more relevant, and they need to be managed and operated with the integrated principle likes of OpenStack. And if you go to conferences like OpenStack Summit, it's not the old guys like HPs and the Oracles who are taking the main stage and getting a lot of attention. It's the small companies that are like 4 or 5 years old, who are getting a lot of attentions because of their solutions that are nice, that are not seen before. Same goes with the big data, because now in order to operate these complex, more software-driven infrastructure, you definitely have to have very good big data capabilities to understand what your network status is and how you want to optimize and change your network configuration so that you can serve your customers better. In that regard also, there are lots of exciting solutions that are coming from small companies. It's not IBM or Microsoft who are creating big data solutions. So I think there definitely a lot of excitement in the startup space, and that will matter more to the service providers going forward.
Ito-san, you want to add anything more?
Yeah. So why we wanted to use open source basis technologies or white box basis equipment means we wanted to reduce, of course, we wanted to reduce CapEx and OpEx too. But we understand it is very hard to reduce those costs even if we use our current technologies. It is not responsibility of vendors. This is our responsibility. We have a reason why we cannot reduce CapEx and OpEx. Because our services and organizations are very, very, individual. So that's why. So, but by using, open source and open white box source equipment basis, we have to make our original services and original architecture or original technologies to provide new services to our customers, time to market. So that's why we focus on open source basis technologies and equipment very, very much. And for the startup companies, we have a plan to provide to our brand new test bed. Right now, we have a plan to expand our test bed to connect from a vendor or startup companies, any companies to connect on a remote basis. So we have a plan to expand our test bed, not only Japan, Asia areas, United States, Europe areas. For example, in case of Silicon Valley, we have a data center in the San Jose area. That's why.
Very good. I guess we have somebody. Okay, go ahead.
Thank you. Neither Guru or the panelists mentioned the problems of cybersecurity and containing attacks. Yet, when you move from dedicated, closed proprietary boxes to open source software running on generic compute servers, you exponentially increase the attack surface. For an SDN, centralized SDN controller, if it's compromised, the entire network is going to go down. For NFV, you converted dedicated appliances into virtual appliances. When one or more is compromised, you may have to lock down others running on that same compute servers. With that as background, what are the three network operators planning to mitigate the effects of cybersecurity attacks?
Yeah, that's a great question. We get that a lot from, frankly, our customers, because they're saying, well, hey, just as you mentioned here, with all this software here, haven't you just opened us up to a whole new attack plane? And our response is, and it depends on what layer you're looking at. This SDN doesn't mean that all of a sudden all your nodes have gone dumb and there's no intelligence there and everything's centrally controlled. You still have distributed control there as well. So the way our approach has been, and I mentioned the network on demand product as an example, we're looking at it as not only do we have distributed control in place, that if your centralized control were to go down, you could still fall back on what you have today. So that's one way. But we also believe, too, that even with software, the initial vulnerabilities, those will get closed, those will be rooted out pretty quickly, and those will be solved very quickly. And also with the additional flexibility, the dynamicism, if you will, the more control you have, we will be in a better position to isolate and contain those types of attacks, quarantine them, treat them, or move other resources away from it until we can get it controlled. So, we're very positive that security will actually be better in a software world.
Kangwon or Ito-san, you want to add something?
Yeah. So to defense those attacks, we have to completely separate the control networks, control layers networks. So, and it looks like, a virtualized closed network, something like that. And also, you have to always monitor the condition of those control layers networks situation. We have original detection software and also defense softwares we developed. So we have to take care of those, how we can defend those control layers more safety. So maybe there are many solutions, but we are now trying to completely separate closed virtualized network should be used control layers, and also we have to some action to find the attack and defense attack. Something softwares we need to install those monitoring layers too.
Do you want to add something, or we should move to the?
Yeah.
Please go ahead.
Yeah, sure. This is a very important question, very hard questions to answer. I don't think there is a silver bullet in this area. What SKT is trying to do is that basically we are applying all the traditional methodology for software development, secure software development, from like static analysis of the code to we are using white hackers to find vulnerabilities in our network right now. It will be more important to going forward, basically. One of the principle that I believe is that open source software is more secure than the closed version, because there are many more eyes looking at them. And like Ito-san said, it's very important that we should be able to monitor our network elements in a real time, in a comprehensive way, so that if there is any like early threat that we can detect, then we need to basically take measures. But it's a very important question. Yeah.
I want to take at least a couple of more questions. Go ahead.
Yeah, I have two related questions to Andre. You talked about virtualization, software-defined network, all your efforts towards that direction. And the question is it related more to a greenfield, or how do you take care of your current and legacy network? This is the first question. And the second related, you mentioned the optical transport, the RAN, and the access network. Do you see these new virtualization and SDN more relevant to these areas as opposed to maybe the core or metro area?
Yeah, those are great questions. So the first question, we're doing both. We're looking at both, obviously. Brownfield is just, obviously we have a large invested network already there. So what we're trying to do is, what can we do to leverage that as the greenfield opportunities begin to grow and mature? So we've been looking at multiple approaches here. I mentioned we have built a open daylight based controller ourselves that we're using here for for brownfield. We're also looking for greenfield, looking at ONS as an option there, as a nodal controller, if you will. And frankly, we're putting our bets in all the places here because we don't believe that just one is going to take over and solve all the problems. We want to play the field here. Regarding your second question about sort of, if you will, the edge versus the core. The core, there's certainly opportunity there for NFV and SDN, and we're pursuing those. But the real cost opportunity for us is at the edge. I mean, if you look at our capital spend, that's where the big investment goes. So we are very eager to find solutions, not just from an economic perspective, because clearly they're there, but also to just really break apart, as the other speakers talked about, frankly, this vendor technology lock-in we have in those areas. And so I mentioned the white box ROADM, the virtualized OLT. Those are great initiatives to sort of break that hold, if you will, because frankly, at the edge is where the action is. Once it goes into the core, things are pretty groomed and streamlined. And yes, there's benefits and there's more to gain down the road there, but the big opportunity really is at the edge for us.
I want to give you a chance for a question too, please.
Okay. Yeah, my question is sort of related to the previous gentleman a little bit. As we start going faster and faster, as we become going from hardware to software, I'd like to talk a little bit about what you're doing on defect prevention, sort of like formal methods. One of the gentlemen mentioned static analysis, and the other was on sort of detection. How is it changing now that we're moving from hardware to software, and how you're looking at anomalies in the system and your plans for self-healing and fault tolerance?
So I think this is my feeling right now. So when we wanted to use white box switches, I think I have not enough the performance of current chips. So because those chips has many functionalities, but those functionality is not much our service providers' requirements. For example, some service providers wanted to use layer 2 basis connectivities. Some providers wanted to use layer 3 basis connectivities. But function of a chip is made a certain ratio of some kinds of resources. For example, cache memory, something like that. So that's why I have strong interest in P4 project. So because in the P4 project, we can control not only for the software basis, but also hardware resource basis, what we wanted to use on those resources. So if those chips and hardware will be coming soon, so service providers are very, very happy, and also speed is more higher to provide any kinds of services to our customers, I think.
Okay, I guess I've been told not to take any more questions, but I will take just one last question if it is very short. And if you can give short answers, that will be the last closing question, okay? Please. Right. Sorry about that.
I was just curious to know what your thoughts are on where the responsibility of reliability for services comes in this new network. Is it in the lower level infrastructure? Is it at the application layer, some combination? What are your thoughts in that space?
If you can give a short answer, that will be great. I don't know there is a short answer or not.
So my quick answer is all layers.
Same for me.
Yes, I agree.
Okay, that was very short. Okay, so I think with that, I want to thank our panelists, and we'll come back in half an hour. Okay.